Okay, we are moving on. That's not what I meant to do. To 9.1. So we're going to do 4 of these problems, and we're going to compare more than 2 categories. So in the past, when we did hypothesis tests to start, we had some value that we assumed to be true about the population, and then we took a sample and we compared that sample to our assumed population number. And we said it's either greater than or less than or not equal to, something like that. And then we moved on to taking 2 samples and we compared them to each other. And we would say that one sample minus the other sample is 0 or greater than 0 or less than 0 or not equal to 0, something like that. But when you have 3 or more categories, it's a little bit hard to compare each category to the other 2 or 3 or 4. And so we come up with this thing called the chi-squared test. And the calculations are quite strange. But we're not doing chi-squared today. We're going to do something called the mean group difference. And as far as I know, the mean group difference is not used by anybody in the statistics world. I've never heard about it until we started this book. But it does sort of give you an idea of how big the difference is. So here we asked a bunch of kids, are you male, are you female, and do you prefer apples or bananas or oranges? So one thing we need to do first is total all of these up. So 60, 50, 40, 150, and I actually don't need the other totals for today. So here, what are the observational units? We talk to students. And what is the explanatory variable, which is the response? So in this case, we're asking, does gender influence fruit preference? Okay, now we're going to compute the conditional probability for boys. The idea today is to see, are apples and bananas and oranges equally liked among boys? So to compute the conditional probabilities, we're going to say, how many apples are there total? Or sorry, how many boys said apples and how many apples total were chosen? So for that one, I'm going to do 25 divided by 60, and I get 0.417. And then for bananas, I'm going to get 0.6. And then for oranges, I'm going to get 15 over 40, and I get 0.375. Now, I could do the same thing with the girls, but do you see how the boy answers and the girl answers are sort of tied together? So there is a test called a test of independence, which is going to compare all the boy numbers to all the girl numbers. But today, we're just going to focus on one line. And for this problem, I've chosen the boy line. It could be the girl line. It doesn't really matter. So those are our conditional proportions. And if we want to know if gender influences fruit preference, what would our null hypothesis be? So we would say H naught. Actually, I need to rewrite that. It should say, what is our null hypothesis to see if all of the fruits are equally preferred? That's what it should say. So we're testing, are these numbers the same? And they're obviously not, but are they far enough away from each other to say that they're not equal? That's what we're doing. So I'll rewrite that question. So H naught says, is the parameter proportion for apples the same as the parameter proportion for bananas, which is the same as the come on, follow the pattern, for oranges. All right, so how are we going to measure these differences? Well, the actual measurement equation is super, super messy, and you'll see that in the next worksheet. So today we're just going to keep it easy. We're going to take the apple percentage, and we're going to find the difference from the apple percentage and all of the other percentages. And we'll do the same thing with bananas and the same thing with oranges. Now, this is not a real value that I'm aware of. So basically what we're going to do is we're going to take the apples and the bananas and find the difference, and then we're just going to make the difference positive. So we're going to take the absolute value. And then we're going to find the difference between the apples and the oranges, and then we're going to find the difference between the bananas and the oranges, and that actually covers everything, right? Now, if we had 4 categories, this is going to get really messy. So we would have A minus B and A minus C and A minus D and B minus C, and it would be a lot harder, okay? So what are the differences? So the difference here is going to be 0.183, and the difference here, so 417 minus 375 is 0.42, and the difference here, oops, oh, 0.042, thank you. And the difference there is 0.225. Okay, so this is the difference between every category percentage and all of the other category percentages. And now we're just going to take the average of those. So 0.183 plus 0.042 plus 0.225, and then I'm going to divide that by 3, and I'm going to get 0.15. So what does that number tell us? That is the average distance of the differences of every category to every other category. So on average, the categories differ from each other by about 0.15. Okay? So if this number gets bigger, then the null hypothesis is less likely. So we're using this number to answer this question. And on this worksheet, we're not actually going to accept or reject the null. In fact, we don't even write an alternative here. So the next question asks, if a second study was conducted and the mean group difference was 0.2, would that be more or less evidence against the null? That would be a larger average difference, so it would be more evidence against the null. Okay, and then you're going to do the same thing on the next 3 scenarios. All right, get to work.